Question 1. A sterile processing technician is preparing a load that includes several large stainless steel wash basins. To ensure proper steam penetration and condensate drainage, what is the mandatory orientation for these items on the sterilizer cart? A. Placed in a standard upright position. B. Loaded completely flat in a wire basket. C. Placed on their edge and tilted slightly. D. Stacked tightly together without wicking towels. Correct answer C. Knowledge point explanation. Core rationale. Solid bottom items like basins must always be placed on their edge. This orientation allows the heavier cold air to drain out effectively and prevents liquid condensate from pooling inside the bowl during the high temperature cycle. Trap analysis. A. Placed in a standard upright position. An upright bowl will trap a pocket of cold air, preventing steam contact. It is correct when setting up basins for use in the sterile field. B. Loaded completely flat in a wire basket. Flat placement traps air and water. It is correct when discussing how to load flat paper plastic peel pouches in a specialized rack. D. Stacked tightly together without wicking towels. Nesting basins without towels creates an impenetrable metal-to-metal seal. It is correct when discussing how to accidentally create a contact failure. Concept extension. If multiple basins must be nested to save space, an absorbent surgical towel must be placed between each basin to wick the steam in and drain the condensate out. Question 2. According to the fundamental principles of microbiology and sterile processing, what is the direct consequence of a surgical instrument entering the sterilization chamber with an excessively high level of bioburden? A. It will drastically increase the cooling time required on the cart. B. It will automatically shorten the required exposure phase. C. It will make it significantly more difficult to achieve sterilization. D. It will mandate the use of 3 additional biological indicators. Correct answer C. Knowledge point explanation. Core rationale. Bioburden refers to the quantity of microorganisms on an object. A dense colony of bacteria acts as a physical and biological shield, making it exponentially harder for steam to penetrate and destroy every single spore, thus increasing the risk of cycle failure. Trap analysis. A. It will drastically increase the cooling time required on the cart. Bioburden affects biological lethality, not the physical thermodynamic cooling rate of metal. It is correct when discussing the effects of overloading a cart with 25-pound sets. B. It will automatically shorten the required exposure phase. High bioburden requires more lethality time, not less. It is correct when discussing the efficiency of dynamic air removal compared to gravity cycles. D. It will mandate the use of 3 additional biological indicators. BI placement is dictated by facility policy, not the bioburden level of a single instrument. It is correct when performing qualification testing after a major sterilizer repair. Concept extension. This concept reinforces why meticulous manual and mechanical cleaning in the decontamination area is the absolute most critical step. You simply cannot sterilize what is not clean. Question 3. A technician is organizing a mixed load containing lightweight absorbent textile packs and dense, 20-pound rigid sterilization containers. To prevent cross-contamination from moisture, what is the mandatory placement rule for this cart? A. Place the rigid containers exclusively on the top shelf. B. Alternate the textiles and rigid containers on every shelf. C. Place the heavy rigid containers on the bottom shelf. D. Place all textile packs tightly against the heated chamber walls. Correct answer C. Knowledge point explanation. Core rationale. During the initial heating phase, dense metal items generate significant liquid condensate. Placing rigid containers on the bottom shelf ensures this water drips harmlessly to the chamber drain, rather than raining down and contaminating the porous textile packs below them. Trap analysis. A. Place the rigid containers exclusively on the top shelf. This is the exact opposite of the rule and will guarantee wet packs on the items below. It is correct when discussing the primary human error causing moisture cross-contamination. B. Alternate the textiles and rigid containers on every shelf. Mixing them randomly will still allow metal to drip onto fabric. It is correct when discussing how to incorrectly configure a load. D. Place all textile packs tightly against the heated chamber walls. Packs must never touch the hot walls, as this scorches the fabric. It is correct when discussing loading practices that cause burning. Concept extension. Additionally, there must be at least 1 inch of visible clearance space between all packages to allow the steam to circulate freely and reach all surfaces. Question 4. An agitated operating room charge nurse calls the SP department demanding that a complex orthopedic set be sterilized in half the normal time due to a severe scheduling error. Which of the following elements has absolutely no scientific impact on the physical sterilization process and cannot alter the validated parameters? A. The complex lumen design of the medical device. B. The exact instructions and demands issued by the user department. C. The amount of dried bone and blood hiding in the hinges. D. The specific resistance level of the microorganisms present. Correct answer B. Knowledge point explanation. Core rationale. Sterilization relies entirely on the strict laws of thermodynamics and biology. A user's urgency, frustration, or demand for speed cannot change the physical requirement for steam to penetrate the device at the exact time and temperature dictated by the manufacturer's instructions for use. Trap analysis. A. The complex lumen design of the medical device. Device complexity directly dictates how hard it is for steam to penetrate. It is correct when discussing factors that mandate extended cycle times. C. The amount of dried bone and blood hiding in the hinges. Soil acts as a physical shield, directly preventing the sterilant from making contact. It is correct when discussing the main causes of sterilant contact failure. D. The specific resistance level of the microorganisms present. Spores are harder to kill than vegetative bacteria, directly impacting the required temperature parameter. It is correct when explaining why highly resistant spores are used for biological testing. Concept extension. The SP technician must be the absolute gatekeeper of quality, regardless of clinical pressure. Skipping steps or shorting cycle times directly endangers patient safety. Question 5. Why is it fundamentally critical for an SP technician to study and deeply comprehend the internal anatomy of a steam sterilizer, including components like the chamber drain, gasket, and jacket? A. To manually override the thermostatic trap during a sudden power outage. B. To chemically titrate the facility's incoming boiler water supply system. C. To thoroughly understand how the machine operates for accurate loading and troubleshooting. D. To legally authorize the technician to perform complex biomedical engineering repairs. Correct answer C. Knowledge point explanation. Core rationale. A sterilizer is a complex high-pressure vessel. Comprehending its anatomy allows the technician to visualize how steam enters, how heavy cold air exits, and why items must be loaded specifically to facilitate this mechanical process, which is essential for diagnosing failures. Trap analysis. A. To manually override the thermostatic trap during a sudden power outage. Technicians should never override safety valves manually. It is correct when discussing highly dangerous practices that void equipment warranties. B. To chemically titrate the facility's incoming boiler water supply system. Boiler water chemistry is handled by the facility engineering team, not SP staff. It is correct when discussing the source of wet steam issues. D. To legally authorize the technician to perform complex biomedical engineering repairs. SP technicians operate the equipment but do not dismantle and repair high-pressure components. It is correct when describing the duties of a certified biomedical technician. Concept extension. Knowing the anatomy directly helps technicians correctly interpret the physical printouts, as they know exactly what the chamber drain temperature sensor is recording and why it dictates the exposure timer. Question 6. An SP technician arrives at 6 a.m. to start the sterilizers for the day. Before processing any actual instruments in a dynamic air removal sterilizer, the technician must run a specific test at 270 degrees Fahrenheit for 3.5 to 4 minutes. What is the primary purpose of this mandatory morning procedure? A. To verify that the mechanical vacuum pump effectively removes all air. B. To kill any remaining resistant bacterial spores in the empty chamber. C. To preheat the internal chamber walls before the first heavy load. D. To ensure the facility's boiler water is free of mineral deposits. Correct answer A. Knowledge point explanation. Core rationale. The Bowie-Dick test is a Type II chemical indicator used exclusively in dynamic air removal sterilizers. It does not check for sterility. It specifically verifies that the vacuum system successfully extracted the dense cold air, ensuring there are no air leaks that would impede steam penetration. Trap analysis. B. To kill any remaining resistant bacterial spores in the empty chamber. Biological killing is verified by a biological indicator, BI, not a daily vacuum test. It is correct when discussing the purpose of daily BI testing for implantable devices. C. To preheat the internal chamber walls before the first heavy load. While a warm-up cycle is run prior to the Bowie-Dick test, the test itself is for vacuum verification, not heating. It is correct when discussing the 5-minute empty warm-up cycle. D. To ensure the facility's boiler water is free of mineral deposits. Steam quality and boiler water are tested via chemical titration, not a physical air removal test. It is correct when diagnosing white powdery residue on chamber walls. Concept extension. If the Bowie-Dick test shows a patchy or non-uniform color change, a massive air pocket remains in the chamber, and the sterilizer must be shut down and tagged out for biomedical repair immediately. Question 7. According to the Association for the Advancement of Medical Instrumentation, AAMI, standards, what are the strict physical limitations for creating a breathable, absorbent textile pack intended for steam sterilization? A. Maximum weight of 25 pounds and no larger than 20 by 20 by 20 inches. B. Maximum weight of 12 pounds and dimensions not exceeding 12 by 12 by 12 by 20 inches. C. Maximum weight of 7 pounds and no specific dimensional limit. D. Maximum weight of 30 pounds directly depending on the sterilizer chamber volume. Correct answer B. Knowledge point explanation. Core rationale. Textile packs, such as surgical linen packs, are incredibly dense and absorb moisture quickly. AAMI strictly dictates that they must not exceed 12 pounds and must measure no larger than 12 by 12 by 20 inches to guarantee that 270 degrees Fahrenheit steam can penetrate to the geometric center and completely dry out post-cycle. Trap analysis. A. Maximum weight of 25 pounds and no larger than 20 by 20 by 20 inches. 25 pounds is the absolute weight limit for a rigid metal instrument tray, not an absorbent fabric pack. It is correct when defining the ergonomic limits for heavy orthopedic sets. C. Maximum weight of 7 pounds and no specific dimensional limit. 7 pounds is too light for a standard limitation, and all packs must have rigid dimensional limits for steam physics. It is correct when discussing the weight limit of loaner trays at specific local facilities, not a national standard. D. Maximum weight of 30 pounds directly depending on the sterilizer chamber volume. AAMI standards limit sets to 25 pounds specifically to prevent technician spinal injuries, regardless of how large the machine is. It is correct when discussing why older tray designs are no longer legally compliant. Concept extension. The density of a textile pack must also not exceed 7.2 pounds per cubic foot. Overriding these parameters directly guarantees superheating or wet packs. Question 8. A sterile processing technician is preparing a cart containing multiple paper plastic peel pouches holding single ring-handled instruments. To ensure adequate air removal and prevent moisture from getting trapped, how must these pouches be oriented in the sterilizer rack? A. Flat with the paper side facing downward. B. A flat with the plastic side facing downward. C. On edge with the paper side of one pouch facing the plastic side of the next. D. Tightly compressed together to fit more items on the cart shelf. Correct answer C. Knowledge point explanation. Core rationale: paper plastic pouches must always stand on edge. Furthermore, the porous paper side, which allows steam in and air out, must face the non-porous plastic side of the adjacent pouch. This ensures the steam pathway is never blocked. Trap analysis: A. Flat with the paper side facing downward. Placing a pouch flat traps condensation on the plastic side. It is correct when explaining how an untrained operator ruins a pouch load. B. A flat with the plastic side facing downward. This also traps moisture and prevents steam from rising through the paper. It is correct when discussing the absolute worst orientation for peel pouches. D. Tightly compressed together to fit more items on the cart shelf. Pouches must have at least 1 inch of space between them for steam circulation. It is correct when discussing the hazards of overloading a sterilizer. Concept extension: specialized metal spiral racks or wire baskets equipped with built-in dividers are highly recommended to hold pouches securely on edge and maintain the required clearance. Question 9. After a steam sterilizer completes its full cycle and the cart is rolled out, what is the mandatory cooling protocol that must be observed before any sterile packages can be physically handled or transported to storage? A. Wait exactly 15 minutes and immediately transfer them to cold wire shelving. B. Place a cooling fan directly in front of the cart to accelerate the process. C. Leave them untouched in a draft-free area until an infrared thermometer confirms they are at ambient room temperature. D. Inspect them immediately using insulated thermal gloves to check for retained moisture. Correct answer C. Knowledge point explanation. Core rationale: warm packages are extremely susceptible to strike-through contamination because warm fibers wick moisture and bacteria from hands. They must remain completely undisturbed on the original cart until they naturally reach ambient room temperature, approximately 70 degrees Fahrenheit to 75 degrees Fahrenheit. Trap analysis: A. Wait exactly 15 minutes and immediately transfer them to cold wire shelving. Dense 25-pound metal trays can take up to 2 hours to cool. Moving them early causes condensation. It is correct when discussing outdated or dangerous shortcuts. B. Place a cooling fan directly in front of the cart to accelerate the process. Forced air blows airborne dust and bacteria directly into the vulnerable warm packaging. It is correct when providing an example of an immediate regulatory citation. D. Inspect them immediately using insulated thermal gloves to check for retained moisture. Thermal gloves will physically squeeze warm moisture straight through the wrapper, instantly contaminating it. It is correct when discussing why bare, clean hands are used only after cooling. Concept extension: the cooling area must be kept away from high-traffic pathways and air conditioning vents to prevent forced convection from shocking the warm items into producing rapid internal condensate. Question 10. Upon unloading a 25-pound heavy orthopedic set, the technician discovers visible water droplets on the exterior rigid container. Why must this wet pack incident be meticulously documented and immediately escalated to leadership? A. Because a wet pack is a critical process failure that requires a root cause analysis to determine the complex multifactorial origin. B. Because the operating room nurse will automatically reject any tray that looks damp on the outside. C. Because it proves the facility's boiler water is chemically contaminated with excessive alkaline. D. Because the sterile processing department will be heavily fined by the local health department. Correct answer A. Knowledge point explanation. Core rationale: a wet pack indicates that the strict parameters for sterilization and drying were breached, meaning the item is unsterile. Because the cause could be the sterilizer, poor steam quality, improper loading, or environmental temperatures, a detailed RCA is legally required to identify and eliminate the systemic issue. Trap analysis: B. because the operating room nurse will automatically reject any tray that looks damp on the outside. While true, rejection by the user is a symptom of the failure, not the scientific reason for the required documentation. It is correct when discussing the customer service impact of wet loads. C. Because it proves the facility's boiler water is chemically contaminated with excessive alkaline. Wet packs relate to liquid moisture, not necessarily chemical alkalinity. It is correct when diagnosing boiler carryover spotting on instruments. D. Because the sterile processing department will be heavily fined by the local health department. Fines occur during audits for missing records, but the immediate goal of documentation is quality assurance and patient safety, not just avoiding fines. It is correct when discussing the long-term consequences of failing to perform RCA. Concept extension. According to AAMI guidelines, a wet pack is never an isolated incident. It signifies a potential failure in the entire steam generation and delivery matrix of the hospital. Question 11. A sterile processing technician is instructed to urgently process a critical titanium orthopedic implant using a dynamic air removal steam sterilizer. According to national standards, what specific monitoring device must be physically included inside the load with any implantable device? A. A Type 2 Bowie-Dick test pack. B. A biological indicator. C. A residual protein detection swab. D. An external tamper-evident seal. Correct answer B. Knowledge point explanation. Core rationale. Implants remain inside the human body and pose the highest risk of catastrophic surgical site infection. Therefore, they must be monitored with a biological indicator, which contains actual live spores, to provide the ultimate proof of lethality. Trap analysis. A. A Type 2 Bowie-Dick test pack. Bowie-Dick is for daily vacuum testing in an empty chamber, not for monitoring implants. It is correct when verifying pump functionality. C. A residual protein detection swab. Protein swabs verify manual cleaning in the decontamination area, not sterilization efficacy. It is correct when testing washer disinfector performance. D. An external tamper-evident seal. External seals only prove the box was not opened, they do not prove steam penetrated the implant. It is correct when verifying post-sterilization integrity. Concept extension. Whenever possible, the implant should be quarantined and not released to the operating room until the BI has incubated and returned a negative result. Question 12. Which specific steam sterilization cycle parameter is strictly engineered to gradually release chamber pressure at the end of the exposure phase to prevent glass bottles from exploding and liquids from violently boiling over? A. Pre-vacuum conditioning. B. Steam flush pressure pulse. C. Fast exhaust. D. Slow exhaust. Correct answer D. Knowledge point explanation. Core rationale. Liquids boil at lower temperatures when pressure is reduced. If pressure drops too quickly, fast exhaust, superheated liquids will instantly boil, causing stoppers to pop and glass to shatter. Slow exhaust safely normalizes the pressure. Trap analysis. A. Pre-vacuum conditioning. This uses rapid pressure drops to pull air out of porous items. It is correct when processing dense surgical trays. B. Steam flush pressure pulse. This is an active air removal method. It is correct when processing lumens without a vacuum pump. C. Fast exhaust. This drops pressure immediately to rapidly dry metal items. It is correct when processing standard solid instruments. Concept extension. Today, most standard hospital sterilizers are not legally validated or approved by the FDA to process liquids. Specialized fluid sterilizers are required for these tasks. Question 13. While transporting a cart of sterilized items, an SP technician accidentally drops a completely dry, sealed paper plastic peel pouch onto the clean floor of the sterile storage area. According to strict event-related sterility protocols, what must the technician do with this item? A. Wipe the outer plastic layer with 70% isopropyl alcohol and place it into storage. B. Inspect the pouch for visible holes and return it to the sterile shelf if intact. C. Consider the item contaminated and send it back to the decontamination area for full reprocessing. D. Place a new chemical indicator tape over the seal and immediately dispense it to the user. Correct answer C. Knowledge point explanation. Core rationale. Event-related sterility dictates that an item is sterile until an event compromises it. The physical impact of hitting the floor forces contaminated air and microscopic floor dust straight through the porous paper layer, rendering it unsterile regardless of visual appearance. Trap analysis. A. Wipe the outer plastic layer with 70% isopropyl alcohol and place it into storage. Wiping the outside does not fix the contamination that was forced through the paper pores. It is correct when disinfecting environmental surfaces like tables. B. Inspect the pouch for visible holes and return it to the sterile shelf if intact. Microscopic tears or air forcefully pushed through the pores cannot be seen by the naked eye. It is correct when inspecting a pouch that was simply handled gently. D. Place a new chemical indicator tape over the seal and immediately dispense it to the user. Tape only secures the package, it cannot reverse internal contamination. It is correct when fixing an administrative labeling error before sterilization. Concept extension. The floor is always considered highly contaminated. Any sterile item that touches the floor, even if inside a protective dust cover, must be fully reprocessed starting from the manual cleaning phase. Question 14. A technician is carefully assembling a complex, multi-level orthopedic tray inside a rigid sterilization container. To accurately verify that high-temperature steam successfully penetrated the most difficult area of the set, where exactly must the internal chemical indicator be placed? A. Taped securely to the outside handle of the rigid container. B. Placed in the geometric center of each level of the multi-level tray. C. Tucked directly underneath the heavy silicone mat on the bottom level. D. Attached to the paper filter located on the lid of the container. Correct answer B. Knowledge point explanation. Core rationale. The internal CI must challenge the sterilization process. The geometric center of the set is physically the furthest point from the steam entry pathways. If there are multiple levels, a CI must be placed in the center of every single level to prove steam reached all layers. Trap analysis. A. Taped securely to the outside handle of the rigid container. External placement only proves the container went through the machine, it proves nothing about internal penetration. It is correct for external type 1 process indicators. C. Tucked directly underneath the heavy silicone mat on the bottom level. Placing a CI under a solid silicone mat blocks it from steam entirely, guaranteeing a false failure. It is correct when discussing improper CI placement. D. Attached to the paper filter located on the lid of the container. The lid filter is exactly where the steam enters first, it is the easiest place to sterilize, not the hardest. It is correct when explaining where external contamination is trapped. Concept extension. Facility policies may also require placing additional internal sea ice inside densely packed corners or near heavy metal masses where excessive condensate might pool and impede steam contact. Question 15. What is the absolute maximum weight limit established by the Association for the Advancement of Medical Instrumentation, AAMI, for a fully assembled rigid metal instrument set intended for steam sterilization? A. 12 pounds. B. 15 pounds. C. 25 pounds. D. 35 pounds. Correct answer C. Knowledge point explanation. Core rationale. AAMI sets the strict maximum weight for rigid instrument containers at 25 pounds. This specific limit balances two critical factors. It ensures the thermodynamic mass is not too dense to dry effectively, and it protects SP personnel from severe ergonomic lifting injuries. Trap analysis. A. 12 pounds. 12 pounds is the absolute weight limit for absorbent textile packs. It is correct when discussing porous load limits. B. 15 pounds. 15 pounds is a distractor weight but is not an established AAMI limit for containerized sets. It is correct if discussing a specific local facility policy that is stricter than AAMI. D. 35 pounds. 35 pounds exceeds the physical drying capabilities of standard sterilizers and creates an immense ergonomic hazard for staff. It is correct when discussing the primary cause of wet packs in orthopedic sets. Concept extension. When weighing a set, the 25-pound limit must include the total combined weight of the surgical instruments, the internal organizing racks, the silicone mats, and the external rigid container itself. Question 16. A sterile processing technician is assigned to perform the daily morning maintenance on a steam sterilizer. During the inspection, the technician discovers a white, chalky mineral scale built up on the internal chamber walls. To safely resolve this and prevent biofilm harboring, what must be used? A. A coarse steel wool scouring pad. B. A non-abrasive stainless steel cleaner. C. Undiluted low-level disinfectant solution. D. A rigid wire bristle brush. Correct answer B. Knowledge point explanation. Core rationale. A non-abrasive cleaner safely removes mineral deposits without damaging the metal. Scratches on the chamber wall create microscopic canyons where bacteria and biofilm can hide and thrive, compromising future cycles. Trap analysis. A. A coarse steel wool scouring pad. This will permanently gouge the stainless steel. It is correct when removing heavy rust from non-medical industrial iron. C. Undiluted low-level disinfectant solution. Disinfectants do not remove hard mineral scale and may leave toxic chemical residues. It is correct when disinfecting external environmental touch points. D. A rigid wire bristle brush. This causes the exact same mechanical damage as steel wool. It is correct when cleaning the internal lumens of heavily soiled orthopedic reamers before sterilization. Concept extension. The daily cleaning protocol must always be performed when the chamber is cool to prevent severe burn injuries and the immediate inhalation of aerosolized cleaning chemicals. Question 17. An SP technician is preparing to process a delicate, 3-pound microsurgical instrument set using a dynamic air removal cycle. The manufacturer's instructions for use strictly mandate a temperature of 275 degrees Fahrenheit. What is the universally validated minimum exposure time for this specific elevated temperature parameter? A. 3 minutes. B. 4 minutes. C. 10 minutes. D. 30 minutes. Correct answer A. Knowledge point explanation. Core rationale. In steam sterilization, time and temperature have an inverse relationship. While 270 degrees Fahrenheit requires 4 minutes of exposure, raising the temperature to 275 degrees Fahrenheit mathematically reduces the mandatory microbial kill time to exactly 3 minutes for dynamic air removal. Trap analysis. B. 4 minutes. This is the gold standard time, but only for 270 degrees Fahrenheit cycles. It is correct when processing standard heavy orthopedic sets at 270 degrees Fahrenheit. C. 10 minutes. This is far too long for standard flash or dynamic cycles. It is correct for specific extended cycles designed to process complex lumens or suspected prion contamination. D. 30 minutes. This is the prolonged time required for lower temperatures due to inefficient physics. It is correct for 250 degrees Fahrenheit standard gravity displacement cycles. Concept extension. The technician must always remember that the 3-minute mark represents only the exposure phase. It does not include the necessary time for conditioning, exhaust, and drying. Question 18. What is the fundamental scientific reason why high-temperature steam is considered an exponentially faster and more efficient sterilant compared to dry heat when operating at identical temperatures? A. Steam creates an impenetrable vacuum seal around the instruments. B. Steam effectively transfers heat and rapidly catalyzes the coagulation of cellular proteins. C. Steam systematically burns and oxidizes microbial DNA into carbon ash. D. Steam physically washes heavy bioburden off the stainless steel surfaces. Correct answer B. Knowledge point explanation. Core rationale: moisture is the ultimate catalyst for cellular death. Steam transfers thermal energy significantly better than dry air and kills bacteria by coagulating their proteins, much like rapidly poaching an egg. Trap analysis. A. Steam creates an impenetrable vacuum seal around the instruments. The vacuum is created by a mechanical pump, not the steam itself. It is correct when discussing the mechanical pre-vacuum phase of dynamic air removal. C. Steam systematically burns and oxidizes microbial DNA into carbon ash. Oxidation is a slow burning process caused by hot air. It is correct when describing the exact lethality mechanism of dry heat sterilization. D. Steam physically washes heavy bioburden off the stainless steel surfaces. Sterilization does not wash or clean items, it only kills what is already clean. It is correct when explaining the mechanical impingement action of an automated washer disinfector. Concept extension. Because dry air lacks moisture to catalyze coagulation, a dry heat oven must operate at significantly higher temperatures for extended durations to achieve the same lethality. Question 19. To save space on a busy Friday afternoon, an SP technician places several paper plastic peel pouches flat inside a 20-pound rigid metal sterilization container alongside the heavy stainless steel instruments. Based on strict sterilization thermodynamics, what will directly result from this incorrect action? A. The paper side of the pouches will fuse directly to the metal instruments. B. The rigid container safety locks will violently rupture under pressure. C. The pouches will trap heavy liquid condensate and create an unsterile wet pack. D. The overall cooling time of the rigid container will be reduced by 50%. Correct answer C. Knowledge point explanation. Core rationale: paper plastic pouches must never be placed inside instrument trays or rigid containers. The heavy metal surrounding them generates massive amounts of liquid condensate, which will pool directly on the flat pouches, destroying their porous integrity and completely preventing steam from reaching the internal items. Trap analysis. A. The paper side of the pouches will fuse directly to the metal instruments. Steam heat is wet and does not cause paper to melt or fuse. It is correct when incorrectly placing pouches on a dry, exposed heating coil. B. The rigid container safety locks will violently rupture under pressure. Small paper pouches inside will not alter the container's structural pressure physics. It is correct when a container's exhaust filters are completely occluded by user error during vacuum pressure drops. D. The overall cooling time of the rigid container will be reduced by 50%. Adding insulating paper and plastic actually slows down the cooling process. It is correct when switching from a heavy metal container to a specialized lightweight aluminum or plastic container. Concept extension. If small items must be included inside a rigid container set, they must be secured upright in specialized small wire baskets designed for internal tray organization. Question 20. According to the strict parameters governing steam quality in sterile processing, which of the following accurately describes the legally mandated chemical composition of ideal saturated steam? A. 100% dry gaseous vapor with absolutely zero liquid moisture. B. 50% dry steam gas mixed equally with 50% distilled liquid water. C. 97% to 100% pure vapor combined with 0% to 3% entrained liquid water. D. Any combination of water vapor that successfully exceeds the 212 degrees Fahrenheit boiling point. Correct answer C. Knowledge point explanation. Core rationale: saturated steam is a precise scientific mixture. If moisture drops below 97%, it fails to properly coagulate proteins. If moisture rises above 3%, it excessively drenches the load, causing wet packs. This specific 97% to 3% ratio guarantees maximum lethality without compromising post-cycle drying. Trap analysis. A. 100% dry gaseous vapor with absolutely zero liquid moisture. This lacks the critical water molecules needed for cellular coagulation. It is correct when defining superheated steam, which acts as a poor sterilant and burns packaging. B. 50% dry steam gas mixed equally with 50% distilled liquid water. This is essentially a flooded machine. It is correct when describing a catastrophic facility boiler failure resulting in massive water carryover into the SP department. D. Any combination of water vapor that successfully exceeds the 212 degrees Fahrenheit boiling point. Temperature alone does not equal sterility. The moisture ratio must be rigidly controlled. It is correct when defining the general physics concept of gas transition, but not medical-grade sterilization steam. Concept extension. Facilities must regularly perform steam quality testing at the sterilizer point of use to ensure the boiler chemistry and pipe insulation are maintaining this exact 97% to 3% thermodynamic balance.